Let's create a procedural pine tree in Blender using geometry nodes. So without further ado, let's dive in and start building this pine tree. First, we'll start by creating a curve line as the base structure for our pine tree. Then we'll add noise displacement to give it a more natural, organic look. Next, we'll add a mesh to the curve, forming the base shape of the trunk. With this, our pine tree's trunk is now complete. Now, we'll model the pine leaves and instance them around the trunk to create a natural distribution. Finally, we'll join the geometry of the trunk and branches to complete the tree structure. At the end of this video, if you learned something, I'd really appreciate a subscribe and a like. Next, add any primitive mesh. We're just using it as a placeholder. Since we don't need the default geometry, we'll delete it right away. Then we'll add a curve line node and use a combine XYZ node to control its end position. For the start position, set the Z value to -0.1. We'll need this later in the process. We'll expose the Z value to the group input and name it branch height to make it easily adjustable. Now, add a resample curve node and expose the count parameter to the group input. Name it height resolution so we can control the smoothness of the trunk. Now add a set position node to create a displacement in the trunk, ensuring it looks organic instead of a straight line. Start by adding a noise texture node, subtracting it by 0.5, and multiplying the value by 0.1. Then multiply it again with an exposed value to control the strength of the noise displacement. And then add a frame around the node by pressing Ctrl+J, and name it Trunk Base Mesh. And then add a curve to mesh node and a curve circle node to act as the profile for the curve to mesh node. Next, add a set curve radius node to control the trunk radius. While we can control the radius with the curve circle node, using the set curve radius node allows us to adjust the taper radius of the mesh. To achieve this, we need a spline parameter node connected to a float curve node for better control. Finally, expose the radius of the curve circle node to the group input and name it trunk radius. And then add a subdivision surface node to smooth out the trunk and enhance its overall shape. And then group them by pressing Ctrl+J and call it Trunk Mesh. And then add an instance on points node and instantiate the curve circle node. Scale the instances using the spline parameter node. Finally, connect the existing trunk radius group input to the curve circle node's radius, so that the curve circles align properly within the trunk's object space. And expose the count of the curve circle node to the group input. This will allow us to control the number of branches per row on the trunk. And then add a random value node to the rotation of the instances to introduce variation and make the branches look more natural. And then add a plane and model the pine leaves. This is just a basic modeling technique. Add loop cuts, move vertices using proportional editing, and duplicate the mesh to your liking with some variations. Then add another instances on points node, connect an object info node with the pine leaves that we modeled now, and set them as instances. Finally, adjust the number of branches in the modifier to control the overall distribution. To control the proper rotation of the branches, add a combine XYZ node, connect it to the rotation parameter of the instances on points node, and adjust the z-axis value. We need to perform some calculations. First, multiply the value of pi by 180 to convert 1 degree into a float value. Then, multiply the interval by the index value so that every branch aligns correctly along the trunk's tangent space. Finally, divide 360 by the branch count to determine the interval between each instance. Next, add a float curve node to the curve circle instances. This will allow us to control the distribution of branches along the trunk. Adjust the curve so that branches do not get instantiated all the way to the bottom. By mistake, I named the leaves count as branch count, so now I'll rename it to leaves count. Then I'll create a new branch count by adding a resample curve node before the instances on points node that instances the curve circle. And then I added some variations using the rotate instances and scale instances nodes, with random values to give it a more organic look. Now, using the join geometry node, I combined the branch mesh with the trunk mesh to form a single connected structure. And then I added materials to the objects to enhance their appearance and make them ready for rendering. Now, add a primitive cube before the join geometry node and use the transform geometry node to move it to the bottom of the trunk. Then, using the mesh boolean node, cut the bottom of the trunk. As I mentioned at the beginning of the video, we set the start position of the curve line to -0.1 on the z-axis. This ensures the trunk has a clean, even bottom. Otherwise, it would have a jagged end. If you want to know how I animated the growing pine, let me know in the comments below. If you followed along this far, I think I've earned a like and a subscribe for this video.